Hey everybody, Mr. Rubo here, and we're going to talk about the first question in the formative for the Essential Standard C. So the first part was to just sketch the graph of the following, and it says clearly label the x and y intercepts. So for this, it is factored for us, so we can hopefully easily find the x-intercepts by setting our factors equal to 0. So x minus 1 equals 0. You get x equals 1. X plus 1 equals 0. You get x equals negative 1. And the last, x minus 4 equals 0. We get x equals 4. So there's your x-intercepts. You do want to pay attention, though, to the multiplicity, which, remember, is based off the power. So this one obviously being 1. Okay. So we have the x minus 1 had a multiplicity of 3. The x plus 1, which gives us the negative 1, has a multiplicity of 2. And then the last, the 4, had a multiplicity of 1. The power was 1. All right. So there we have our three x-intercepts with their multiplicities. Now this negative 2 out in front will not affect the x-intercepts because there's no x with it. Okay. Really, this is only going to affect the values away from the x-intercept. So like the y-intercept, we'll have to multiply by negative 2. But it doesn't really affect the x-intercepts themselves. Really, the negative is going to affect the leading coefficient, so it'll affect the end behavior, but it will not affect these x-intercepts. All right, so let's go ahead and throw some tick marks on here, preferably evenly spaced. And we have a point at 1, negative 1, and 4. So there's that one, and there's that one. All right, so now the other thing we should find is the y-intercept. So we just set each of these equal to 0. So you're going to get, I'll just do it right above, so negative 2, negative 1 cubed, then 1 squared, and then negative 4 to the first. So that was just substituting in 0. So now when I do this, that's going to be negative 1, that's negative 2, so that would be positive 2, that's positive 1, that's negative 4, so 2 times negative 4 is negative 8, which means my y-intercept is going to be all the way down here at negative 8. So let's change to red. All right, so then the last thing you want to look at now is that dealing with that 2, that negative 2 out in front, you want to make sure what your leading coefficient is, so that way we know our end behavior. So here we have leading coefficient of negative 2. The other coefficients, you always want to check those, but they're all 1s, so the negative 2 is the only thing that is going to affect our leading coefficient because these are all 1s. So 1 times 1 times 1 times negative 2 is negative 2. So it's a negative leading coefficient. And the degree is going to be the powers or the multiplicities added together. So it is a degree 6th. So this right here is that power function that corresponds to it. Well, because it's degree 6, it's going to end either both up or both down. We know it's negative, so it's going to end down and down. So now we just connect it using our multiplicities. Okay, so as we go from this side going up, we get to 1. I'm sorry, we get to negative 1. Has a multiplicity of 2, which means it should bounce. And you should hopefully be able to tell that it bounces even because of this y-intercept, because you went through, you'd end up here, and there's not a way to get back down. So we can clearly see we go down. How far down, it doesn't really matter for right now. You just want to go through the y-intercept. You come back up, and then at positive 1, it was the multiplicity of 3. So you should squiggle, wiggle, however you want to say it, through. So it should look like a cubic. Then we go up, we come back down. Once again, it doesn't matter how high. If you actually graph this one, I think it goes up to like 300. But we don't need to worry about how high for right now. And then the 4 had the multiplicity of 1, so we're going to go straight through, and we end up pointing down like we wanted to. And yeah, there we go. So, and that's our graph. So hopefully you enjoyed the video and have a nice day.